So let's continue on with our dihybrids. Last time I said we're going to do our dihybrids two different ways. One way is the Punnett square. And the way I'm going to teach you, I'm going to call the FOIL method, like from algebra. And then we're going to do the tree method, also called the branch diagram method. And remember, we're going to do that with the product rule. So let's go ahead and do one more example, well, a few more examples of the product rule. Remember, product means to multiply. Last time we did an example that if a family has two children, both of them will be girls. This is what we did right here. Probability of the first one being a girl is a half. Right, half. Probability of the second one is also half, so then you multiply those. And what if the probability is that they have three children and they're all going to be the same gender? Okay, let's say they're all going to be, let's say all three of them are going to be girls. We're going to have three girls. We're going to multiply them. Okay, what is the probability of the first child being a girl? It is a half. Second one being a girl is a half. Third one is also a half. Right here. A half. 50-50. Product rule. You're going to multiply those. 1 times 1 times 1 is 1. Now make sure you don't add these bottoms here, these denominators. 2 times 2 times 2. That's going to be 8. So what's the probability that they're all going to be boys? Boy, another boy, and another boy. You remember, it is the father who determines the gender of the offspring because he has a Y to offer, where the mother only has X's. So the probability of the first child being a boy is a half. Second one being a boy is a half. Third one being a boy is a half. Product rule, multiply these. So the chances of having 3 children, them all being boys, 1 times 1 times 1, 2 times 2 times 2, then don't add, make sure you don't add, 8. Let's review how to do the FOIL method in algebra. So let's say we have a plus b times c plus d. So what we did was, there's our FOIL, FOIL. Now at the F, so look, our firsts. So first we're going to do the firsts. So firsts. So this one right here times this one right there. Alright? This one here times this one here. Our firsts. Next, we're going to take this A right here. We're going to do the outers, that one with this one. Alright? That's our second one, outers. So first, this one and this one. Then the outers, that one with that one. Alright, next we're going to do the inners. Here's the inners, look, the 2 inside ones. Then we'll do the last ones, the 2 last. So there's the last one of that group, and there's the last one of that group. So our firsts is here. That's an O outers, then our 2 inners, then our 2 lasts. So FOIL method. So the FOIL method of multiplying 2 binomials. Go ahead and look at that. First with that. The first with the first. Outer with the outer. Then inner with the inner. And then the 2 lasts go together. So 7x times 2x get 14x squared. Over here, I'm going to get 14x squared. And then outers over here, 42x. And then the 2 inners. And then the 2 lasts. Okay, now let's go ahead and apply this idea to our biology, to our dihybrid genetic problems. Let's say we had a dihybrid that is heterozygous for this particular trait. Right now we don't care what the trait is. So first, right, just like over there. Then second, our outers. Then third, our inners. And fourth, our lasts. So if I were to set up a Punnett square, and color here. So if I were to set up a Punnett square, and let's say both of the parents are heterozygous. I'm not going to do any of the work right now, I'm just going to show you how to set it up. Notice I'm making a much bigger, I'm making a much bigger Punnett square. Okay, so what we did here, we did this first. So right here, I have to have one of each of the letters, the big R and the big Y. See what I did right there? That was our first. And then our second was going to be yellow. So big R with little y. And then next, those two inners. And lastly, I have to move that up so you might not be able to see it. Make another bar here. So I'm going to do these right here. So I'm going to have a little R. So notice there is a pattern here. Okay, let me get you different colors so I can show you the pattern. It's always going to follow this pattern. Let's see, I'll use white. Okay, notice we're going to have, look at these two right here. These two, the first ones are going to be dominant. Alright, and then these two, the first one is going to be recessive. Everybody see that? So we're going to have dominant, and then we're going to have two dominants, and then we're going to have two recessives. We're always going to need this order. And then let's try to get another color here. We'll use that one. Now notice the pattern here. We're going to have a dominant, lowercase. We're going to have a dominant, lowercase. Alright, so it's really, really important that you understand this pattern. These two are dominant on the first trait, and these two are recessive on the second trait. These are dominant, see, dominant right here, recessive, dominant, recessive. Okay, let's go ahead and do some problems. So let's take a look at these. First one, if one parent is homozygous dominant, and then the other parent is homozygous recessive, let's go ahead and take a look at that. Alright, let's use A's and B's. So it says one parent is homozygous dominant, so we're going to use A's, and let's use B's. I'm just going to use the same color, just to save time. Alright, homozygous dominant. Notice we put the two same letters together, and we're always going to go capital letter before lowercase. So the two rules, alphabetical order, uppercase before lowercase. And one parent is homozygous recessive. So two little A's go together, two little B's go together. So these are the parents. We don't need to do any Punnett square or anything like this because this one's really easy. Because this parent, different color here, this parent can only give big A's. So all the offspring have to have at least one big A. Remember, they're only going to get one from each parent. So one of each of these pairs. Alright, so each of those is going to have a little A. Alright, look over here. Let's do a different color. This one right here only has dominant alleles to give. Remember, each offspring is only going to get one of them. And this one only has little b's. Okay? So all the offspring, all the F1s would be heterozygous for both traits. If both parents are homozygous dominant. Let's take a look at that. Okay, so let's have both parents be homozygous dominant. Again, this is a really easy one, and we do not need to do any Punnett squares. Here are the parents. F1 of the offspring. So in this case, that one can only get big A's. In the alphabetical order, that one can only get big A's. So they're only going to get one letter from each parent. So one of the A's and one of the B's. This parent can only give big B's. And this parent can only give big B's. So all of them have to be homozygous dominant. And then our next one, it says we're going to cross a heterozygous. And it's going to be heterozygous for both traits. Let me get a different color here. Alright, it says we're going to be heterozygous. One of the parents is heterozygous. And it says that the second parent is homozygous recessive. So what does that mean? For both traits, okay? It's going to be 2 little A's and 2 little B's. So let's set up our Punnett square and do our FOIL method. And you need room for 4 letters in each of these boxes. Hopefully I have enough room. I think I will. Alright, so we're going to set up a big tic-tac-toe. If you want to put boxes around it, that's totally fine. So, FOIL method. That first one with that first one. So big A, big B. That first one. So FOIL, firsts, outers, and what's next? FOIL, what's next? FOI, inners, little a, big B, and our 2 outers, the last ones, I should say, the 2 last ones, 2 little A's and little B's. Now the next one is actually quite easy to do. We don't need to do all this. We can do a shortcut for that one. Go that one with that one. It's going to be the same. Right, little A, little B. Look at that. It's going to be little A, little B. Little A, little B. Little A, little B. So we don't need to do 4 times. See, they're exactly the same. And I'm just going to use white for the inside here. Notice, that's lowercase, uppercase. So the uppercase, go to lowercase, alphabetical order. See how I did that? Should have made my boxes a little bigger. This one, I should probably use a different color just because my boxes are so small. Big A. Little a, does everybody see what I'm doing? Little a, little a. big B, little b. And then 2 little a's and 2 little b's. And they will be exactly the same all the way down, so we do not need to do this. So instead of being out of 16, it will be out of 4. Okay, now let's go ahead and do a heterozygous times a heterozygous, and now we're actually going to do a little more work, and we're going to use some different letters. And this page is in your handout. Alright, so we have 2 different traits, round or wrinkled, or yellow and green. The parents, in this case, they're going to be homozygous. One is homozygous dominant for both traits, the other one is homozygous recessive for both traits. So let's look at the parents. I mean, not the parents. Let's look at the F1s. Let's do a different color. F1s. This one can only give big R's. That one can only give little r's. This one can only give big one, the dominant allele. This one can only give the recessive allele. And then what we're going to do is we're going to cross these 2. So all the offspring are going to be this. And we're going to cross 2 of the offspring. 2 of the P's. Alright, that's what we're going to do. And we're going to be using our FOIL method, and we're going to set up a big Punnett square. I'll do it right here. Let's make it orange. And then let's do our FOIL method. Add the 2 firsts. And that first and the last. And then the 2 inners. And these 2. And since they're exactly the same, go ahead and put the same down the side. And then we're just going to fill it out. You can go across, or you get bored going across. You can go down. Just make sure that you have alphabetical order. Put the same letters together. R's go together. Y's go together. Alphabetical order. Uppercase before lowercase. Alright, I got mine all filled in. Next, what we're going to look for, we're going to look for these patterns. The pattern that I showed you earlier, we're going to look for that pattern now. We're going to look for all those that have this. One big R and one big Y. We're going to look for, and always do it in this order. One big R, 2 little Y's. Alright? Those are the 2. Alright, remember the pattern. The first 2 have the dominant allele, then the dominant recessive, because this is dominant allele. It doesn't matter what the second one is. And then we're going to look for, we use 2 different colors here. Look at the pattern. Remember with the next 2, the first 2 are 2 little R's. Then they're going to follow the same pattern here. One big Y Okay, and then you need to know what they're going to look like. But for right now, let's just go ahead and find those patterns. So I'm going to go look in this big dihybrid. I'm going to look for all those that have at least one big R and one big Y, and I'm going to put a little purplish pinkish circle there. So they just need one big R and one big Y. So all these so far, they have to have one of each. So let's count 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 out of the 16. And what are they going to look like? I have it here. They're going to be round. I put a big R for round. I don't have room to put the word out. Round. And they're going to be yellow. Okay, let me get a different color now. And we're going to look for all those that have one big R and two little Y's. And for those, I'm going to put an orange's X. So they have at least one big R and they have two little Y's. That one right there and right here. So we have 3 out of 16. The first trait is going to be dominant. And I don't have room to write the whole thing out. They're going to be round. And the recessive trait was green. Now we're going to find the next traits. So both of these have, the first trait is recessive, so they're going to be wrinkled. So let's go ahead and look for that. I'm going to put a tealish square looking thing here. It's supposed to be a square. There. Oh, here's another one. So we found 3 out of 16. And they are going to be wrinkled and green. No, not green. Yellow. And then look right here, a little triangle. We only have one of those. So 1 out of 16 are going to have both recessive traits. They are going to be wrinkled and green. So a ratio, they all have the same denominator, so it will be 9 to 3 to 3 to 1 ratio when both parents are heterozygous for both traits. Okay, now we're going to do this a different way. So this was doing it the Punnett square way using the FOIL method. And now we're going to do the same thing using our branch method, our tree method. So we're going to have the same parents. Both of them are going to be heterozygous for both traits. And we're going to be using the tree method. What we do this way is we use our product rule. And what we're going to take our first traits separately. And we're going to set up a Punnett square for each of the different traits. Don't need such a long line there. So we're going to do 2 monohybrid crosses. That's what we're going to do. So we don't need the tree method. So look, this is big R, little r. So big R, little r. this one, big R, little r, fill out our Punnett square. For our test, when we do a dihybrid, you only need to know the phenotypic ratios. You will not need to know the genotypic ratios for the test. So we're just going to be doing the phenotypic ratios. So for doing the phenotypic ratios, we know these three have the dominant phenotype, right? So 3 out of 4, I can put it over here. 3 out of 4, and I'll move it down a little bit. So 3 out of 4 are going to be round. And 1 out of 4 are going to be wrinkled. And then what we're going to do is we are going to get a different color here. Do another monohybrid cross for our second trait. I'll use my orange again to make my boxes. Just different color. So just our second trait, big Y, little y, just doing these ones right here, and these ones, big Y, little y's have the tails. And my little ones have little tails on them. So in this case, we have two possible traits. We have yellow and green. In this case, we only have two branches because we have two possible traits. So we're going to have 3 4s. And just because I'm running out of room here because we got to do some other work on this side, I'm just going to put a Y for yellow. And I'm going to put a G for green. And we do the same thing down here. 3 4s, yellow, 1 4 green. Now here comes our product rule. And we're going to be finding out how many are going to be round and yellow. We're going to find out how many are going to be round and green. 2 little y's. We're going to find out how many are going to be wrinkled and yellow and wrinkled and green. How are we going to do that? By applying the product rule. So 3 times 3 is 9. 4 times 4 is 16. 3 times 1, 3, 4 times 4 is 16. 1 times 3, 3/16. 1 times 1. That 16 is kind of funky. So only 1 out of 16 are going to be wrinkled and green. And notice we have a 9 to 3 to 3 to 1 ratio. Notice these two are the dominant traits, these two are the recessive traits. Dominant, recessive, dominant, recessive. And let's go ahead and see. Look, with all that work, we did it exactly. We got exactly the same results. Sometimes the trait method is easier, but sometimes actually the Punnett square is easier, even with the dihybrid, if you can do a shortcut. If you can do a shortcut, sometimes the dihybrid way is easier. Now let's go to the second page of the genetic handout that we were working on for the last video. And we're going to now start to do dihybrids. So here we're going to be looking at Cocker Spaniels. Get a different color here. In this case, black is dominant. Let me get a little darker color here. So that means Big B is going to be black. Big B is our dominant allele. Black is the phenotype. And if it's complete dominance, which it is, we know that they only need one big B. So it could be homozygous dominant or heterozygous. And it says red recessive. So it'll be, that's a B, not a G. It looks like a G. Let me do it over. So that is red. There's only one way to get one way to get red, and that is homozygous recessive. So that is our first trait. Our second trait it says right here, S solid, big S is solid. Solid is the phenotype. Dominant allele, phenotype. Here's our genotypes. Just need one, homozygous dominant or heterozygous. And little s, white spotting. So white spotting. Only one way to get that, and homozygous recessive is the genotype. So let's go ahead and look at it. Starting right here is our problem. It says a red male. So it's red. Alphabetical order. And it just says red. So that means it's red solid. So here's the parents. Made it to a black. So we know there's at least one big B. And white. Well, we know that's recessive trait, so we know that one is homozygous recessive. They had 5 puppies. Their first puppy was black. And it's just plain old black, so we know that's black solid. So let's see if we can find any clues. Well, This parent here can only give the recessive allele, so we know that that puppy got a little B, alright, from the dad. And the mom can only give little S's, recessive allele, so we figured that one out. That puppy is heterozygous. Our second puppy. Red. So it's red solid. So we know that's two little B's. One big S because it's solid. Let's look for some clues. Let's use that. Alright, we had to get a little B. Oh, look, we can figure out that parent had to have a little B, right? We figured that one. Figured out the mom. And also from the mom can only give little S's. So we know that one got a little S. So we got that one from that parent. Got that little S from that parent. Alright, so we did those two. Now we have a black and white puppy. So black, that has a big B, and white. And we know that one has to be two little S's. So look right here. That has two S's. The two little S's had to get little S recessive allele from each of the parents. So we can figure out what the dad's second one is. This one right here, also looking at the dad. The dad had two little B's, so all the offspring have to have at least one little B. Got it from the dad. And we have two red and white. So puppy 4 and 5 are the same. And they are going to be red, so we know they are two little B's. And they're also white. So we figured out the genotypes of the puppies, and we figured out the genotypes of the parents. So this is a good one to know. That's why that's circled. Alright, we're not going to actually do this one right here. But I want you to write this word in the margin right here. Write this word, epistasis. Epistasis. So go ahead and write that word, epistasis. We'll talk about that later. You can do a test cross with a dihybrid as well. Dihybrid. For our class, you might actually have to do them, but make sure that you know that they are possible. For example, we knew with a monohybrid, it was to figure out what the second allele was for the dominant phenotype. And with a dihybrid, you can also try to figure out that allele as well. So when we did our product rule and the tree method, we don't have to just stop with the dihybrids. We can go on and do trihybrids. We have 3 monohybrid crosses and we multiply those. The FOIL method is a really good way to indicate the independent assortment. So the dihybrid crosses very clearly show the independent assortment. So the genes for the different traits, the alleles, they're going to be inherited independently from each other. Alright, so they can be independent from each other, and that's how we could do the FOIL method. This example, we got a big A from that one, little a from that one, big B here, a little b here. So they are going to be inherited independently from each other. The A's and the B's are independent of each other. Alright, so I showed you two different ways to do the dihybrids. We could do our branch method over here. Method. Our Punnett square method over here. And we did our tree method over here using monohybrid process here, multiplying using the product rule. And remember, this was for parents that were heterozygous for both traits. Alright? This only works if both parents are heterozygous for both traits. And if we're talking about complete dominance. All the genetic problems that we've done so far, when we have one allele, the dominant allele, completely dominant over the other, that is called complete dominance. And then actually, an even easier way than actually having to do any of this work, if you know it is complete dominance, and if you know that both parents are heterozygous, get some space here, you will know that it will always be a 9 to 3, maybe a little space in between here, without having to do any work, you'll know it's a 9 to 3 to 3 to 1 ratio. And if you remember when we did our chi-square test in the lab book, the last two problems we did were 9 to 3 to 3 to 1 ratio. Now you need to know what this means though. And just follows the order that I said that we're going to follow right here. It's going to follow this order right here. So 9 out of 16 are going to be dominant for both traits. So it's going to follow this pattern right here. You have to know the pattern. Let me make my marker a little bit smaller since I made my picture a lot smaller. So for this one right here, this is always going to be dominant for both traits. I'll just use the R's and the Y's again. So it's going to be dominant for both traits. So let's just do the pattern. This is what we said. So remember the pattern. These two are going to be dominant for the first trait. Right? And these two are going to be recessive for the first trait. Another color. And then follow the pattern. This one is going to be dominant for the first trait. Second trait. And this one is going to be recessive for the second trait. So dominant, recessive, dominant, recessive. So just make sure you know the pattern, and then you won't have to do any of that work if it is complete dominance. And you'll get a 9 to 3 to 3 to 1 ratio. And you could always do your chi-square test to see if it actually fits a 9 to 3 to 1 ratio. Everything is not as simple as complete dominance. And before, we're going to be talking about some gene interactions. We're going to find out where it's not really what might be expected with complete dominance. So we're going to start before.